So now we're going to talk about what's called doubling time. So let's look at our model that we have, A equals A naught e to the kt. And now we're talking about, well, we want the amount, the original amount, to double. So maybe we want an account that we're going to double our money in so many years. Or maybe a population is going to double in so many years. Okay. So the amount that we're trying to get is going to be twice the original amount. So this works similar to like half-lives. You can divide both sides by A naught, and then you can solve that equation. If you take the natural log of both sides, then you're going to get the natural log of 2 equals kt. Now, that formula, you could do one of two things. If you're trying to solve for time, you would say the natural log of 2 divided by k. That's provided you know the constant, right? But you could also take that formula and say k is equal to the natural log of 2 divided by 2, divided by t. In this formula, now we know time. But not the constant. So this is probably more likely. We probably are going to know how long it takes something to double, and then we have to figure out the constant. The constant could be given to us, k, in a formula, but probably that's going to make more sense to us. Now, you can put that into your formula, but I'll do that later. Okay. So we want to keep that formula k equals the natural log of 2, because I kind of know what problem is coming here, over t. And that's going to allow us to calculate what k is. So according to Moore's law, the doubling time for the number of transistors that can be put on a computer chip is approximately 2 years. Okay, so that's what they found, like research. You can double how many transistors can be put on in 2 years. Okay, that it represents then the time. That's how long it's taking something to double. All right, give a function that describes this behavior. Well, we want to figure out what k is. K then is going to be the natural log of 2 divided by 2 because of the years. Now, you can't simplify that. You could get an approximation for it. I would get an approximation for it. The book doesn't do that, but I'm going to do that. So the natural log of 2 divided by 2, and it's about 0.3466. Okay. So that's approximately what k is equaling. However, in our formula, I'm going to erase it. Erase that little 0 there. It equals A naught e to the k. Well, what are we going to use for k? Do you want the exact? They want the exact. So we're going to say natural log of 2 divided by 2 times t. And that's how I would write it. So that is the function that describes this situation where we're doubling the number of transistors that can be put on a computer chip. Okay. So if you know what you're starting with and you know how much time has gone by, then you can say this is how many transistors can be put on a computer chip. Okay. There's the function.